Assalamu alaikum. Today we are going to study some main topics of subject physics class first year. These video lectures are also useful for MBBS test. These lectures are in very simple words by which anyone can take help. If I missed anything in this video or you don't understand anything, so comment in the comment section. So let's move to our lecture. Let's explore 15 questions of physics with answers. What is Newton's law of universal gravitation? Newton's law of universal gravitation states that every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of distance between their centers. What is the formula for Newton's law of universal gravitation? The formula is F is equal to G m1 m2 divided by r2, where F is the gravitational force between two objects, m1 and m2 are masses of objects, r is the distance between their centers, and g is the gravitational constant. What is the mass of Earth? The mass of Earth is approximately 5.97 exponent 10 power 24 kilograms. How does the gravitational force change with distance according to Newton's law? The gravitational force decreases as the distance between two objects increases. It follows an inverse square law, which means that doubling the distance would result in a quarter of original gravitational force. How does the value of g change with altitude? Height above Earth's surface. As you move higher above Earth's surface, the value of g decreases. This is because g is inversely proportional to the square of distance from the center of Earth. How does the mass of an object affect its gravitational force? The gravitational force between two objects is directly proportional to the product of their masses. This means that increasing the mass of either object will result in a stronger gravitational attraction between them. How does the distance between two objects affect their gravitational force? The gravitational force is inversely proportional to the square of distance between two objects. As the distance increases, the gravitational force decreases rapidly. Why do astronauts experience weightlessness in space despite the presence of Earth gravity? Astronauts experience weightlessness in space because they are in constant state of free fall around the Earth. The spacecraft they are in, such as the ISS, is also falling toward Earth due to gravity, but the high forward velocity prevents them from getting any closer. As a result, they are in a continuous state of falling, creating a sensation of weightlessness. If you like this video, then please like, subscribe, comment and share our channel, Dr. Raza Academy and Educational Consultancy.